Hello, welcome to a new pre-algebra video. This is lesson 4. We're going through the Math UC homeschool curriculum, and it's pretty awesome. We have added negative numbers, we have subtracted negative numbers, we've multiplied negative numbers, and now we're going to divide negative numbers. It's going to be so great. If you would like to go and get a notes page to use and follow along with me with this, I have the link in the description, and it possibly will also pop up, assuming that I remember to put it up there. But dividing negative numbers, here we go. All right, I'm big on talking about like the why and the reasoning behind what we do. So I think we kind of get caught up sometimes on just like not even remembering what some of these things are. So then when we add new stuff to it, like now there's negative numbers instead of just positive numbers, it can be tricky, right? So let's take a step back and say, okay, what even is division? So division is when we separate things into groups and we are attempting to put them into groups where there's an even amount in each. We don't want uneven groups, we want even group. It's the idea that I've got 6 things, and if I want to divide them into 2 groups where I have the same number in each group, well, ta-da, 3 and 3. So 6 divided by 2 is 3, because if we put it into 2 groups, then we've got 3 things in each group. Although actually we can think of it slightly different and we could say 2 is what I want in my group. How many groups would that give me, right? If I have 6 people, I want 2 people in each group, I'd need 3 groups. And that actually has to do with the fact that multiplication goes either way too, right? That we can say 3 times 2 and we can say 2 times 3 and those mean the same thing. So that's what division is in general. So how do we know we're being asked to divide? Well, the word divide could be in there. That's certainly a possibility. But we have symbols that we use. For instance, the division symbol, which is the bar with the dot on top and dot on bottom. That's the way we can divide. But another common way to see it, and it will be more and more common as you go from here on out, is that instead of writing it with the symbol, we might write it as a fraction with the first number, the thing we want to divide up, is on top, and the second number is on bottom. So the groups, or how many are in each group, is on bottom. So that's another way we can write it. But in our Math UC workbook that we're working through, they've also got it written out some as a division problem that looks like this. And so when you see that kind of notation, you may be thinking, long division. I think all of these work out really nicely, so you don't need to worry about that. But that's just a reminder that, hey, this means to divide. So why would we need to divide negative numbers? Just as a quick note as well. And so if you watched my video on multiplying with negative numbers, we have kind of similar times when we might want to divide negatives that we do when we multiply negatives. Because really the reason why we multiply or divide in general is the same, because division is kind of like multiplying, but just where we have a fraction. By kind of like, I mean like it is. We could write everything as multiplication instead of division, but we choose not to because sometimes it's easier to think of it as division. So the reasons we multiplied in real life problems that we talked about last time is when we have something that's the same rate that's happening over time or over distance or whatever it might be. That's when we would choose to multiply, because we're doing the same thing each time. And instead of having to add different amounts each time, we just multiply because it's the same amount. So instead of multiplying, we might divide because we know different parts of the problem. So for instance, there is a formula for speed and time and how far you've traveled. Distance traveled equals rate, or speed, if you want to think of it that way, times time. Okay, so the idea would be that we would multiply in this situation if we knew the rate and the time. So if you know your speed and you know how long you're going to travel, if you multiply those together, it tells you how far you've gone. 60 miles per hour for 2 hours, you should have traveled 120 miles. I almost said miles per hour. Should have traveled 120 miles. We might divide though if instead we know how far we want to go, and we know either the speed or the time that we want to have, but we're missing the other piece. So maybe you know what the speed limit is on the road you're going to travel, and you know how far you need to go. Dividing tells you how long it should take you. Or on the other side, maybe you know how far you need to go and you have a certain amount of time before you're late. dividing tells you what your average speed needs to be, and that can be a really, really frustrating thing to calculate while you're on your way late to somewhere. Okay, so that's kind of why we would use division. It's really just because we know different parts of a multiplication problem. So why would we use negatives in division? What would that mean? What would that look like? And so it could be that we have a negative as in like we're talking about something starting off negative, like debt. And so we want to divide and see, okay, how much do I need to pay off each week in order to decrease some amount? That would be a negative kind of a rate thing, and so that might be the case. So I don't want to get too caught up on this because I could talk for a really long time about this, and it probably doesn't need to happen right here in this video. So I'm going to do my best to make a separate video about why we multiply or divide by negatives and why it ends up that the rules are the way they are. And you can check that out. If/when I get it, I'll have a little thing that pops up so that you can go check it out. But basically, we just need to come up with what are the rules, like with our other operations, what are the rules that negatives follow? Okay, we already know what happens when we divide two positive numbers because that's what we've been doing up until now. A positive 20 divided by a positive 4 would give us a positive 5. So we already knew this. A positive divided by a positive gives us a positive answer. But these other situations where we've got either a negative first or a negative second, or they're both negative, those are different situations. And if you did watch the multiplication video before this is where it would be great for you to actually think about what does your like math intuition tell you the rules should be. You may be going, I don't have any math intuition. And maybe you're right. But I have a feeling that you, if you really try, you could look at this and say, okay, here's what I think should happen based on what I already know. And if you're just not confident about saying what that is, that's fine. That's fair. But that's one of the skills we develop as math students and mathematicians is saying, I'm approached with something I don't know. What do I think should happen based on the rules I already know? And it can be interesting to see how often you're right, how often you're wrong, how far you're wrong, that kind of thing. So here we go. If I have a positive 12 divided by a negative 2, first off, this is kind of a weird thing to think about if you're trying to say take 12 and divide it into negative 2 groups. That's not really gonna, work out super well thought-wise, because how do you have negative 2 groups? But it also kind of is weird to think, well, how many negative 2's are inside of 12, since 12 isn't negative? So our answer kind of, if you need to think of it this way, because it doesn't really make sense as a question, that might be your trigger to know that, okay, this answer needs to be negative. So this is a negative 6. Also, all division problems can be rewritten as multiplication problems, right? Negative 2 times what gives you a positive 12? The answer to that has to be negative 6 because we said a negative times a negative gives us a positive. So that's another way we can think of to make sure we understand why it needs to be negative 6. Same kind of thing here on 3, sort of. Negative 9 divided by 3. This time it does work to say if we have negative 9 of something and we divide it into 3 groups, what should be in each group? We should have a negative 3 in each group, right? Each of these groups has negative 3. So our answer is a negative 3. And then finally here, number 4, negative 16 divided by negative 4. I've got a negative divided by a negative. And just like with multiplication, when we have two negatives, they go away. Here, these two negatives are going to cancel each other out, and they're going to give us a positive answer of 4. So here's how it works, right? Two positives divided give us a positive. 2 and 3 are where we have a single negative and a positive, and both of those ended up being negative. And then finally we had 2 negatives, and that gave us a positive. This is, what's awesome about this is it's consistent. The same thing was true for multiplication. 2 negatives make a positive. 1 negative makes a negative. And actually the same thing also we talked about when we were subtracting. Because in our subtraction problems where we had things like 2 minus negative 5, remember those two negatives canceled each other out and we said those could be a plus instead? Same kind of thing is happening here, that two negatives are making a positive. So what's great is these rules are consistent, and that makes it be less work for us having to internalize these rules and know that they're true. Okay, so let's actually go through and do some of these. As soon as you feel like you're ready, you should pause the video and try these ahead of me and see if you've got the hang of it. Because that is, we need to test that our intuition is right. So you got to develop I think this is what should happen, I think these are the rules, and then test to see if what you think the rules are is really true. Okay, so here we go. On A, negative 77 divided by negative 7. Now, one way to think of all of these that might be helpful is to think of it as actually two separate things. First, divide the numbers in general. So 77 divided by 7 gives us what number? If that's the part, by the way, that you're having trouble with on all of these, that is a different issue than if you're getting the positive or negative part of it wrong. If you're getting the division itself wrong, then that means you need to practice your multiplication tables, or just do more math in general, because that's something that that somehow you've got to get the hang of, right? That 77 divided by 7 is, and know that answer. But the other part of this is saying if it's positive or negative. So a negative divided by a negative gives us what? Well, it gives us a positive, and 77 divided by 7 is 11. So the answer to this one should be a positive 11. I'm going to come over here to B, negative 100 divided by 10. So two different questions. What's 100 divided by 10? And should this be a positive or a negative? So since it's 100 divided by 10, that's 10. One negative makes it negative, so this is negative 10. C, positive 54 divided by a negative 9. So 54 divided by 9 is 6. 9s, by the way, have a really cool trick to them with multiplication tables. And then there's one negative here, so that makes this negative 6. And then negative 33 divided by negative 3. Well, 33 divided by 3 is 11. A negative divided by a negative makes a positive. Those two negatives, they're like, hey, what's up, bro? Let's go hang out. And then they leave the problem and go play Xbox or PlayStation or whatever you want to call it. And it's just a coincidence that there are two 11s on this page. Perhaps it's because I'm making these up myself and I like the number 11. Who knows? Example 2, just more division, same old, same old. Now, these top two where they look different, remember that the inside number is what we're dividing up, and then inside is what we're dividing up, outside is what's being divided into. So we're saying 16 divided by negative 2 here. The answer to that is 8, but it's a negative 8 because we have a single negative. And then B, negative 6 into negative 36. So that gives us 6, and it's positive because these are both negatives. Two negatives make a positive. Negative 64 divided by positive 8. Well, the number part of that is 8, and a negative divided by a positive, there's one negative, so this is negative 8. 32 divided by 2. If you need to come over here to the side and do this division, that's totally fine. If you do that, I actually would recommend you leave the negative out of that because I feel like it just gets in the way. And so what we want to do is kind of ignore it and then answer that negative question later, right? So 32 divided by 2 is 16 because it goes in once, and you subtract 2 and you bring down your 2. 2 into 12 is 6. But because it's a negative on bottom here, we're dividing by a negative, this would be negative 16. All right, the moment we've all been waiting for, now you try. So pause that video, give this a try, and start it back up either when you get stuck or when you have the answers. Let's go. All right, 5 into negative 25, my answer is 5 with a negative. B, negative 42 divided by negative 7, they're two negatives, make a positive, so that is 6, positive 6. And then C, positive 24 divided by negative 6 and ends up being a negative 4. I will say this, by the way, if you are just now seeing negative numbers for the very first time and are having some trouble here, this may be something that takes some time for you to get. And that does not mean that you're stupid. That doesn't mean that you're not good at math. It just means that you need some time to get used to this. In some ways, what we've done is completely opened our world up to a whole new set of possibilities by saying negative numbers are a thing. That's kind of a big deal when you think about it. So if you are having trouble with it, don't feel bad about that, but do try to reach out for help, okay? So you can always leave a comment on this video. If you're actually in my math class, you can send me a message and I'll help you out. But just know that this is not something that everybody gets super fast or super easy, and that's okay. A couple other things. If you are doing the Math UC Pre-Algebra course with me, in this section, they ask some questions about integers and whole numbers. So let me just really quickly kind of tell you the difference between those. They also have a number line at one point and ask you to put dots. Oh, almost skipped over 3. Put dots on the number line. I think that's pretty straightforward. I'm hoping, if I asked you, hey, can you put a dot at negative 4 on this number line? Well, that would go right here. We just put a dot there. Okay, but the thing it asks us that I wanted to talk about is the difference between whole numbers and integers. Whole numbers, which is a word you should have heard before, are things that are 0 and above that represent whole, a whole thing. So I think it's the easiest way to think of it is not fractions or decimals. Whole numbers are everything else. They're the numbers we like. 0, 1, 2, 3, 4, 5, and so on. Those are whole numbers. Whole, W-H-O-L-E. Integers are the same types of numbers, but we include the negatives for integers. So negative 4 would be an integer, but not a whole number. So integers are positive and negative and 0. But otherwise, it's kind of the same group that we're talking about, that they're not fractions or decimals. Okay, and the same with whole numbers. Those are not fractions or decimals. Hey there. Thanks for watching this video. If you haven't already, you should subscribe, maybe leave a comment if you're interested. And I hope you'll join me next week when we talk about the next thing on our list of things to do, which, spoiler alert, is exponents. Bye!